All right, so now that we've looked at the descriptive statistics for our numeric univariates, I'm going to jump around with the steps a little bit because I want to continue talking about our univariates. So strictly speaking, with our step 4 descriptive statistics, I would then move on to my bivariate descriptives and look at correlations. But rather than that, I'm going to jump down to step 5 and look at graphical displays of univariates, just to stay on topic. So we're going to just look at 3 examples, and I'm going to use the OVC variables. But I challenge you to go away and actually have a look at all the other variables as well. For the sake of time, we're not going to go through all of them. And really, this is just to identify modality, but also to talk a little bit about looking at normality from an eyeballing perspective. So if I run my histogram statistics, histogram syntax, which we looked at last week, this is my distribution for surveillance. Now, to me, this is suggesting that it is, in fact, unimodal. There is just a one-hump data camel. It looks a little bit positively skewed, but negatively skewed, because the tail comes out to the negative end. But really, it's because of these two. Like, if we got rid of these two columns, this, I would say, is otherwise basically normal. So I doubt that this is going to be an issue, and I would probably analyze this as if it was normal, but it does look like there is a bit of a negative skew. Now, if we were to go back to the statistics, this is surveillance. Surveillance skew statistic was in fact negative. So by eyeballing the graph, I'm going, okay, this looks like it might be negative. And if I sit them side by side, and the skew statistic confirms this, it does look mesocodic to me, and the kurtosis statistic is about 3. So I would say this is perfectly fine. Now, something that you can do, and you don't have to do this, is you can use, first of all, frequency. So as a subcommand, if we just look at the default here, we have density, which essentially is a proportion or a percentage. But if we use frequency as a subcommand, that's going to change density to the actual number of people in each column or each bin. We can then use bin 10 to change the size of the bins or the size of the columns and exactly how many numbers they represent. So in reality, when we look at these columns, it's not that each column represents a single number. Often the columns represent a range of numbers. And so you can just play around with the bin size to change how many numbers these columns represent. Of course, if you go too wide, you'll get a single column, and then you go, oh, it can't be normally distributed, it has no variability. So you do have to sort of play around with it a little bit. Sometimes this is necessary to actually see what the distribution looks like, but sometimes this can be misleading. But let's have a look and see what it does. So this is now the distribution that we get. So we have widened the bins a little bit, and we can now really clearly see that this is it's a unimodal distribution with a negative skew. So if I go back to here, without the bin size, some students would go, oh, actually it might be bimodal because of this gap. And as I was saying before, a gap like that is not enough to say this is bimodal. It's still unimodal. And when we widen the bin size, we actually confirm this. It is in fact unimodal. If I widen the bin size and it was bimodal, those two distributions would be even clearer. Let's very quickly look at shame. So shame looks really platykurtic with a positive skew, but otherwise looks unimodal. And finally, control. Control, slight positive skew, actually looks a little bit leptokurtic, actually. But also unimodal.